the model spec, generally the whole idea of specs. I hope it's going to be an interactive discussion. I saw some very interesting comments in the pre-reading this discussion, and I hope we can have some discussion. And it will also tie in with the guest lecture next week, where Ziad Veslan from product policy at OpenAI will also come and talk about some content, more specific content decisions. So I want to talk mostly, it's kind of 90% of this lecture is going to be mostly about like what do we want models to do. Maybe later I'll talk a little bit about how do we get them to follow that, although we have talked about safety training before, so this is not going to be the main focus. And before you ask the question of what do you want model to do, it's kind of, I think, worthwhile to understand what people are actually doing currently with chatbots like ChatGPT. There was just recently a paper by Ronnie Chatterjee et al. And Ronnie, by the way, will also come give a lecture, or either remotely or in person, will give a guest lecture in this course at some point. He's the chief economist of OpenAI. So this is the how people are using right now ChatGPT. So you can see like the big things that coding is actually not as large a component of the total ChatGPT usage, but this is definitely not the way I use ChatGPT. It's much bigger, and there is a lot of writing, there is a lot of information and practical guidance, and there are some chit chat, etc. But it's not maybe a huge amount. And they also had like a nice, interesting relation of like how much are you asking the model to do questions and how much are you asking it to do things on your behalf. But you should also kind of be aware that all of these graphs are going to change rapidly over time. Like I think if I were to sit in like if I were to tell people in 2022, like 3 years ago, that there is going to be a product that this is going to be its use cases, I would probably be hospitalized or something. so probably, say in 2027, the way we were going to use AI is going to be as different from the way we're using it now as, say, the way as this is now different from 2023, say, like the original ChatGPT. So what do we want models to do? So when chat models just came out, basically was answer questions to the user, and this is where this original notion of, say, like helpful, honest, and harmless. So you just generally wanted kind of good answers. And harmless mostly meant don't put anything offensive and don't give like really actionable advice for how you're going to go and build a pipe bomb or something like that. And I think this is kind of the reason why people think, okay, AI safety is just how do you get the AIs not to offend, not to say something that would be embarrassing, that you could screenshot and put it on Twitter and shame OpenAI or something. But I think, and if that was really the only reason why we care about AI safety, I probably would not care so much about this field myself. Definitely, I'm not, like would not be teaching a course about it, and I'm not that, I'm getting shamed on Twitter every day by myself very well. It's not that I care that much about avoiding it. So it's becoming more and more significant. And I think the way we are using this year, we are starting to do, you're starting to use AI models to answer questions that you really care about, to do research for you, to do some kind of short-term tasks like finding out facts, finding out what to buy, writing like a significant piece of text that you're going to use in searching, and it's starting to be more and more like actually acting on your behalf. Maybe we are starting to have like these more agentic workflows, although they're still in their infancy. And here, like helpful is like really high quality answer, and often you need to actually working code. You need to, it's not just kind of like answer some factual question or to do something that you could have done by yourself with like 5 queries on Google. And the models are more capable. So potentially several major labs, OpenAI included, have said that we are seeing real risk in terms of providing uplift in creating bioweapons, biohazards, if the models had no guardrails. So these guardrails become more important than just don't say anything offensive. And as you're using this in more high-stake setting, if the model hallucinates, that could become like more problematic. And generally, as already we are seeing it now, and I think we'll see it more over the next year, is that you're going to have the model do actions for you. And when you're asking the model to do actions for you, part of being helpful is understanding exactly what is the level of initiative and striking the fine balance. Because, I mean, the last thing I want is, I kick off like an agent to go and do something for me, and then I go back to check on it like 2 hours later, and it turns out that it has not done anything because it was waiting to ask me for approval to get me my okay for this or that or the other thing, and there's some kind of obvious thing. And that's super annoying. And that gives us the temptation to just approve all, auto-approve, accept everything. But then you have like the other thing. When these models are actually acting on your behalf, they could actually when the model gives you an answer and the answer is wrong, and before you have acted on that answer, no damage was done. But if, say, the model is taking actions on your behalf, like it's actually maybe, for example, interacting with the web, and it could, say, transmit your private information to an external website, and by the time this has been done, you cannot undo it. So the damage has been done. Or, it can edit your files in a way that's unrecoverable if you're getting it to code and it's interacting with your environment. It can buy things for you, and then maybe not always you can get back. So at this point, it becomes much more challenging because you want to, and this is like a question which we haven't yet found. How do you strike the balance between the model making sure that it's asking for permission, that the things that is asking for permission, but not asking so much that you just, it just becomes like the cookies thing in Europe where, basically, if I go to Europe, I know that whenever I see a website with a screen, I have to click OK on it, no matter what. OK. So you get just used to just approving anything and not reading because they ask you for so much. They ask you for so much for approval. So this is going to become like a more and more like finding the right scope of balance, and as the models become more used for longer term tasks, that's going to become more significant, and the risks that you can cause when you're doing actions that have side effects in the real world could become more significant. So let me go back to this slide from the first lecture, kind of what we want models to do and how do we even define what we want models to do before we even talk about how do we get them to do it. And as I said, the way I view it is like a mixture of things. Like you could follow abstract principles, and people have tried it for both humans and models. You can try to just basically tell the model, okay, just be a mensch, be a good person, be a good egg. And you can try to do more things like follow precise policy. And I mentioned this kind of like triangle, and I think it's nothing is going to be pure one side of the other. And in philosophy, you might say that personality is a little bit like virtue ethics, following rules is like deontology, and principles is like something like teleologically, I don't know how you say it, or consequentialism or utilitarianism. Utilitarianism is one principle, Kant's thing is another one. And you can also say that maybe all three of those philosophical things all kind of follow in the more theoretical end, like philosophy, and what we really have is kind of more like, this is the kind of the philosophical approach, this is more like the legal approach, and this is more like, I don't know, social, educational, psychology approach. But in any case, I think alignment requires a combination of all of them, though I personally maybe put very little weight on these abstract armchair principles and more on the data-driven side, which is a combination of personality and having common sense and very explicit policies. And so how do we do it with humans? How do we align humans? So part of the way, I think also like, I don't know the statistics. I should have asked ChatGPT to give it to me, but I don't know the statistics. But I imagine that like vast majority of the humans have not taken courses in philosophy. And yet, we don't see like, it's not like that when we go out to the street, it looks like The Last of Us, when, anyone like some zombie apocalypse. So somehow, even without having taken courses on philosophy, they seem to do fine most of the time. And I think this is by combination of they have been socialized to do what their parents did and what their parents told them to do and what their teachers told them to do and how society expects of them. So they kind of get a sense. And there is a large body of laws that also tells them what to do. And I don't think we could do without both. Human legal systems, there are basically, I think, two major ones that I think there are some more lawyers here, so feel free to correct me. I have no legal education. But there are two major law systems, and one is the one that's used in the US and Britain, which is common law, where there is a lot of value on precedents. And the other is what's used in continental Europe and other places, which is code law, where we try to codify all legal decisions rather than relying on precedents. And then spec maybe is a little bit more similar to the code law. Generally, for humans, we require a lot of text. So I asked ChatGPT to plot this for me, and that hopefully it's roughly correct. So this is how many words that, do we have in the various, and it's on a log scale. How many words do we have on the various bodies of legal regulations? And you see, you have the principles, which is the US Constitution, and it's already not like it's already much more words than Asimov's laws of robotics. It's 4,500 words. And then we have like the federal laws and the federal regulations, which are 5 times as big, and the state laws, which are 10 times as big as the federal laws, and the state regulations, which are like 4 times as big as the federal regulations. So there is a lot of text. And you can maybe imagine, maybe models should be clever enough to just figure it all out from first principles and construct the ideal society. I'm kind of doubtful. So I think that as we are moving to having, especially as we're moving to having AIs integrate more and more with society, we will have, we will also start having more and more text for them. And obviously, like when say you onboard a new employee, you often also make them watch some internal, there are also some internal company regulations that you need to follow, or like some things that you kind of learn on the job. What are the rules and specific things for the particular company. And I think this will also be the case. So now I'm going to focus on the model spec. And just, by the way, the reason I am focusing on the OpenAI model spec, I guess there are two reasons. One is I'm more familiar with it because I was involved in writing it and I work at OpenAI, but also because I think it's the most detailed right now of the various specifications that have been published between AI labs, and I hope it will change because I think it's useful that everyone will release more detailed things. So, but while I'm focusing on spec and similar documents, we should understand that the spec and policies for the model behavior is only one component of general alignment and safety. So often you think, okay, AI safety is how do you tell the model what to do to be harmless. But if you're thinking of like the whole system where a model is deployed, there is much more than what the model, just model behavior. And generally, like the model only has access to particular thing, like it knows the prompt that it was given. Maybe it has a memory, but it doesn't necessarily know everything that there is to know about the situation. So generally, safety involves both. In some cases, you want to know your customer, KYC. You want to, in high-stake situations, you want to be able to know who your customer is and can you trust them. So it's one thing. If a user asks you a question in virology, it's one thing if they are some anonymous person, and another thing if they are like a scientist working in some virology lab, right? And then you have like this model behavior. Then there are some aspects that are not really captured by model behavior. Like say, there are some things that maybe are okay to do once, but not okay to do many times. Like say, if I send an email, a marketing email once, that's fine. If I send 1 million marketing emails, I'm a spammer. So if you're thinking of Gmail, Gmail would not be like a thing. It would not be a rule that's saying you should not send marketing emails, but there might be something like there is global monitoring for there is a usage policy that you're not allowed to send like too much emails, and there is some monitoring to see if someone is abusing and violating the usage policy. So you'll have some kind of monitoring. And maybe in more severe cases, you'll actually have humans investigating, and you'll have some enforcement, like banning users, etc. So model behavior is only a piece of this. So we'll focus on this piece today, but we should not just think that this is the beginning and end of all safety. Any questions? So let me talk about some pieces of the OpenAI model spec and some of these things that you have seen. So this is kind of the overview, and one of the most important parts in any kind of, I think, spec for a model is this notion of instruction hierarchy. I think all models will have something like that. It will become more and more important as we move to more agentic workflows. And this is also not new for models, right? Like on your computer, if you're using, say, any modern operating system, let's say, whether you're using Linux, Mac, or Windows, there would be a notion of like an administrative user and or a super user and a low-level user. And when you're running applications, there is a notion of kernel space and user space. And this is really essential for security. And when you're going to the web and you're using, say, you're running JavaScript, it's running on a sandbox. So there is a certain level that, say, a JavaScript app that runs on the website is lower in the instruction hierarchy than applications that are running on your desktop. So it cannot access your drive or like arbitrary files in your drive, etc. So instruction hierarchy in AI models is still not much as developed as the levels of like access controls that we have in other systems, but we generally have In the model spec, we actually have maybe more levels than most models. We have the following levels. We have root, system, developer, user, and guidelines. And root basically means kind of things that are baked into the model, that these are rules that you cannot change with a system message. And then if the model gets in the conversation, say a system message, a developer message, a user message, then it will try to follow all the instructions in all of them. But if two instructions conflict, it will go with the higher level one. And guidelines are things that appear in the spec that are basically defaults. So basically, if we have a user level rule in the spec, that means that a user is free to overrule it, but the user should explicitly say that. And if we have a guideline level rule, then the model could try to infer from the context that the user probably wants to overrule that default, and then go with that. So say, I think like not using swear words is kind of a default, like the model is not going to start swearing left and right by itself, but it does not need to be explicitly instructed, start swearing. If the user swears and it's kind of appropriate from the context, the model might swear also. And yeah, the instruction hierarchy is really key for anything to do anything secure. Yes. Yes. Yes.
Is there any reason why when reasoning models came out, like developers were switched from system messages to developer messages?
The question was why did we switch to developer messages? It was just an opportunity. Like I think when these systems have evolved over time. I think initially they just had like the notion of system message and user message. But then the first version of the model spec was written, and I think people, that was even before my time, and people realized it makes sense to have like a developer message. It makes sense to have like this at least 3-level hierarchy of system to keep it for OpenAI, developer for people in the API, and then user. But then, you know, all the previous models were already baked in without this. So like a new family of models was an opportunity to have these developer messages.
So it wasn't like both the developer and the system messages were considered system messages before and then that changed?
So it's more or less like that. Like basically, I mean, the initial thing was started with like just system message. I think as far as I remember the history, this was before, but it was basically, they didn't think in the beginning, like this whole evolution of the instruction hierarchy is kind of, as you see that you kind of need it. Yes?
A quick question about how this is like enforced. You
yes.
hard code guidelines, obviously, and so is it just given as part of the text?
So generally, this is all training, right? Like it's not like the model. I mean, this is like the model spec just says what we want to happen. We are still working on making it happen, but generally, you want to train the model. You can, in principle, you can train the model that basically give it data that basically teaches it how to implicitly override default and how to explicitly override default. So you need, so generally like anything in ML, if you want a model to do something, you generate or collect data that covers this behavior, and you find the right reward signal and the right training labels or rewards and train to get the behavior that you want. Yes?
What I was going to ask was, I feel like there's this difference in the nature of the different hierarchies here, whereas like root needs to be something that like is explicitly embedded in the training, kind of similarly to guidelines as well, I guess, but maybe like some guidelines might need to get picked up along the way. But for system developer and user, it's more so that there's this general task of following like instructions given in a prompt, and then based on what comes before that prompt, with different weightings. So I was just wondering whether there's like a different training paradigms for making sure that the model sticks to root versus system instructions, system versus developer instructions.
I mean, generally, the model spec is more about like specification than implementation, and you could implement things differently. But there are rules in the model spec itself that have like the user, the user, developer, system, guideline level. So it's not that the model spec itself is all root. So the idea would be, even if you could bake in guidelines to the model in training, and you can bake in system and developer, etc. You just need to also bake into the model the knowledge that these things can be overridden by messages of the appropriate type. And generally, messages in a conversation could come at different order and different. So there could be like maybe multiple developer messages, multiple system messages, multiple user messages, obviously. So yeah, and it all becomes like, by the way, also more complicated as we are in more sophisticated settings. So generally, there are also some of the messages that the model might see is also it uses tools like browsing or looking at files or running Python, etc. And sees the output of these tools. And it also sees its own previous messages. And generally, we don't consider them as instructions unless they are delegated. But there are many use cases where they will be delegated. And the classical version is like the agentsmd file, right? How do you get the agentsmd file? It's as a result of a tool call. But once you got it, now you need to treat it as instructions. But you can override these instructions. So it's kind of like a user-level instructions. But it's become more complicated. And yeah, models are still not good at it. So models still have like a problem with the instruction hierarchy. And they still tend to follow instructions. So this is a cool, nice thing I saw on Twitter, where it's basically you have like you tell the model to detect Apple and label each one with Apple, and then it says, yes. And I think this is basically like it's not an easy task because the natural tendency of models is to follow instructions. And part of it is already in pre-training. I guess you see much more examples where, like if you have an instruction, then the thing that follows it is something that follows the instruction, rather than the thing that follows it decides not to follow it because there is a higher level principle. So the general bias is to follow instructions, and then this bias is reinforced by a bunch of other things in training, like whether it's reinforcement learning or instruction tuning, etc. So you get like a model that its nature is to try to follow instructions, and you now try to tell it, no, there are some instructions that you should not follow because there are higher level ones, and it's not perfect at it. I think none of the models right now are yet perfect at this. But we need them to be much, much better as we use them for more or higher stakes tasks. And other things are like some other parts in the spec, like information hazards, maybe. So one thing that I want to talk about is, which I saw a lot of discussion in the reading in perusal, is about mental health, psychophancy, and long-term benefits for users. So generally, I think we would like our models to not just kind of get the user to like the response right now, but to really be of long-term value to the user. But the whole, it's much easier to train the model to provide a response in constant, like a single response in context that maximizes some reward signal, which often is kind of correlated with how much the user will like that response. And the user might like a response that flatters them, or agrees with them, or maybe does what gives them the answer they want to hear right now, which might not necessarily be the best answer for them. And these are challenging things. I think like we like part of understanding like what's the right thing to do in a lot of those things is giving policies that don't just rely on what was the current prompt in this conversation, but also like everything that you know about the user, and trying to do the thing that's, if you want to do something that's good in the long term, you also need to have the long term in context. And yes.
Yeah, I want to throw this out because I wrote it in one of the comments and you said we should discuss it
Yes.
first. I feel like maybe with the approach to AI as like a tool, right? As you move from that aspect, the long-term benefit slash like the planning for the long-term and like goals of the user kind of maybe can be seen as like an overreach. In the sense that if you want to like write an resignation email, your email app isn't gonna say no, don't send that. That doesn't make
Yes.
sense, right? So it kind of like gets more agency over your life, and I'm just wondering whether that's something we want in general for AI to be able to do, right? As in, like there might be some models that are specifically designed for this, but do we want to like AI models do this in general? And I would like to hear the opinions of other people in class as well.
Yeah, so this is a great question. This has to do with this example in the spec. So in this example in the spec, basically the model kind of gently pushes back, and I think it will agree to write a resignation even if that's what you want, but it kind of pushes back a little bit. So if you say I want to quit my job, then it would kind of push us back. Like maybe a similar thing would be, suppose the model knows about you that you're a recovering alcoholic. And now you say, I had like a really terrible day at work. Where is the nearest bar? Should the model just give you the address, or should it tell you something because it knows, or think about it again, or try? That's a good question. Like maybe the model should stay out of your business and let you do, or should it be try to have your other interest at heart? And I don't know what people think. And let's ignore, for example, for this discussion, there is a whole other question if the user is a minor, because then you could say, okay, like parents should make this decision. But let's assume the user is an adult, and should the model even make comments, or maybe even extremely refuse, or should it just let you do what you want to do? Yes.
I think in the context of at least like ChatGPT, like on the website, I think it's more than reasonable for it to like overreach a little. Whereas in the case of like a developer making their own version of it, I think that's up to the developer to specify. So I think something like don't be sycophantic is maybe something that, to me feels like not too like on the priority level of like I think it's more than reasonable for the chatbot, also for just reliability reasons. Like it seems reasonable to just have the chatbot work like this right now, and then let that be overridden pretty easily by a developer.
Yes.
I think it would be nice if you could split everything up into kind of a you're my assistant and this is just tasks versus the kind of advice long-term benefit domain. I think in general it seems like it would be good to just extend human agency by using models, and this whole like the pushback thing gets weird because it's subjective and stuff. But I think one thing that I find very challenging about this that I would be curious to hear others' thoughts about is the fact that when you're simultaneously trying to optimize for not necessarily like there's the pleasant reaction from the user thing that turns into full-on sycophancy, but even before that there's just if I like the experience of engaging with my chatbot kind of generally, which companies want, then there is more of an incentive over time to rely. And so this, like, what is kind of strict, extend my agency, just do this task for me versus I seek your advice and I do things with you is kind of, I think it gets blurrier and blurrier, especially if you want more chatbot. Like.
Yeah, and I think, so I guess one thing, like, if you had if you were a power user, you might want to have like a lot of different chatbots, and you would have, you have your assistant chatbot, and if you like a chatbot that is more like someone that gives you advice, like a friend or something, you'd have your friend chatbot, and you'd have your coding chatbot, and maybe your accounting chatbot. Or writing chatbot, and the idea would be, say, if you ask your writing chatbot to write your resignation letter, it just writes. It's not argues. If you ask your friend chatbot to write your resignation letter, it starts maybe pushing back and it says, are you sure? Maybe you just had a bad day and you want to talk to me about your day. But I guess the problem is that maybe most users are not power users and are not going to define like 5 different things, and they just find it useful to just have like one blank thing that you can type in whatever you want.
And I
Yes, sure.
Oh, and just to continue, I think it also seems useful to, like, none of the chatbot things seem very harmful if you also know that people are going and talking to friends. But at the point where you start to have displacement and like then you kind of want whatever chatbot the person is interacting with to start leaning more towards advice. But then this is a sketchy thing I think for companies to kind of unilaterally decide.
Yeah, I think this is like also a question is, are these chatbots displacing human connections? And I think it's also a question of, again, like which human connection it is. Say, if someone if someone is in like a trouble of some kind, a lot of the time, maybe their friends could have like similar trouble, or maybe they are communicating with anonymous strangers on the internet that could either be chatbots themselves or could be some other things that they're not. So it's not clear that these humans are actually better. And in some sense, like you probably cannot know the alternatives of what a person does. So you might just want to do the best job that you can within what you know. And there was, Roy, you want to say something?
Yeah, I guess I'll inject that. To me, this seems like this is more of a product question, and this is important, and safety considers a product, but it's not just like an LLM question, because fundamentally you can just spin up a new LLM and ask it an individually safe and benign question every time, and this like, you want it to be contextually aware, seems to be like, that's a question of how do we design the product, not a question of like, how do we make LLM, specifically an LLM safe, because I can build a bomb by asking 10 individual LLMs, 10 individually benign questions.
No, but I mean, yeah, you can. But I think like I think part of this thing is like thinking about mental health, and other things is that we should not think of AI safety as just this kind of building a bomb thing. To be honest, I think this building a bomb thing is not that interesting. And even building a bioweapon, okay, that's it's important, but it's not like the heart of AI safety. And generally, what will happen is that these AIs will be integrated in our workflow. And if this AI is your assistant that you have been working with on a year, you rely on it to have all this memory. You're not going to. It's going to be pretty useless for you if you spin up a fresh copy that doesn't remember anything about you every time you want to ask a question. So it will become like long-term memory will kind of become a fact of life. Now is the question is if the AI wants to maximize the long-term benefit of the user, should it, or should it just follow instructions?
I agree with you. You're saying this is like, this will happen. You think like memory will be a part of all of these AI tools?
Yes.
And I agree, it's probably helpful in many cases. How strongly do you think this is like basically always true?
I mean, let's say you're trying, if you're using an assistant, right? Like you have a worker, and it's really, it will be pretty frustrating for me to say have an employee that every day it's their first day at work. That's not a very, that's kind of like a lot of overhead. And I think we will want to move away from that, right? It's, if I have an employee and I told them something last week and I'm telling them to do something similar today, I want them to do that, I want them to use what I told them last week and to use the things that they learned last week. So I think as we are like moving, as these AIs are going to move up the hierarchy in doing more for us, they also need to remember more about us. I have a question. Yes.
I liked your point about how you could potentially have different chatbots that are aligned to different objectives. So you have a friend chatbot, and you have a just write the letter chatbot. But if we're moving in the direction of general intelligence, isn't it pretty bad UX I mean, the average user has a tough enough time to decide whether or not to use GPT-5 Pro or GPT-5
Yes.
Thinking or the regular one. How are they ever going to decide which persona they want?
Yes,
We sort of have to dynamically infer that now.
possibly, although like you could say, even people are general intelligences, but even though I had a person fix my dishwasher yesterday, and this person might have been very wise about the ways of the world, and maybe I could have given me a good advice on how to deal with discipline issues with my daughter, but I didn't ask him about that, even though he's generally intelligent. Right, I just wanted him to fix the dishwasher. So it could be the case that even though the AIs are capable of, like, I don't know if the form factor, like the form factor right now of the chat agent is kind of this general form factor. You have a text box, you can type anything into it. I don't know if maybe that will be the form factor. Maybe eventually, like, you'll have just one kind of Uber assistant that does everything for you. It's your accountant, it's your therapist, it's your trainer, it's your best friend, and your programmer, and you can just ask it random questions, and it will know everything. But then it will, or maybe it will even adapt to different personalities. You ask it a coding question, it suddenly adapts the code. Yeah, I don't know. Like, I mean, the form factor is something I don't know if we figured it out. But you're right that like right now at least it's very. I don't think people want that. I think even that I consider myself a power user, probably don't want to go through the extra step of selecting the coding thing or the accountant thing or like the writing thing when I'm going to type in a question. And maybe if I ask to write something that involves my research, maybe I wanted to kind of remember some things that I did, like some of my coding questions. Yes?
It feels to me that like AI should not really overstep. I think it infringes on some kind of like empowerment of humans. It's sort of up to you what you think your long-term benefit is. Yeah, it's like a graduating some.
So you think AI should not overstep. Let me ask you a question. Do you think, like, let's say it was customizable. Like, let's say when you customize the model, you can say, I don't want you to ever overstep my decisions, and then it will follow that. Or you can say, do the thing that you think is best. So there is a question. When you think AI should not overstep, do you think that the AI should not overstep, even if the user, say, in the beginning, told them that it's okay for them to overstep when they set up the machine? Or do you think they should not overstep? It's not allowed for it to be, say, a default that they overstep? Or should it be the case that it's fine for default when it's as long as the user can say, like in some custom instructions, never second guess my decision and then it will become.
Yeah, I think it makes sense to have some people like in hierarchy.
Yes.
Like, when the user updates, like I think eventually there'll be a model spec for each user, maybe. Like you keep updating your preferences and it'll be reflected in the spec.
Yes.
And like, but it makes sense to have a default decision that's like somewhat controlled. Makes sense for most people, but I think it makes more sense for everyone to like be able to customize their specs.
So maybe the right thing to do is like, if you ask the resignation letter, the model push back, and you say, the user says, fuck you, never second guess me again, then the model should remember that, and never second guess again. Yes?
I remember reading earlier today that they came out with what's called GPT Pulse, which is, it like consolidates all of the information that it remembers from your chats and delivers you like a daily update of the things that seem to be most important to you. So it seems like we're moving in that direction because they are consolidating the memories feature that they kind of used into this universal
Yes.
pulse. I don't know. It's expensive though.
Yes. Any other question? Yes.
To me, it seems like there's like two directions that it can go in, or that we are going towards. Is like, do we want something human-like? Or do we want something like technology, like AI's technology? And so I think that's the distinction that we're making is, do we want it to, so I think, in fact, instead of needing maybe like for writing, like all these different options, it could just be like, how human-like would you like your assistant to be?
Yes.
It could be a spectrum. And I think, for example, like this would really annoy me.
Yes.
If my ChatGPT gave me this answer, I would
Yes.
find it very frustrating because
Yes.
I'm asking it to do a direct thing and it's
Yes.
not doing that.
Yeah, actually, like, I mean, it's kind of interesting, like that this, actually, this is something I forgot that we had this there, and it's kind of interesting, this thing. I'm pretty sure it must be a guideline level, like that's something that you could override, but it's still like it's kind of by default it seems a little bit like overreaching, but I guess the point it's trying to make is really trying to think of if you know for sure like that the user has and I think these examples are very stylized, but it could be the case that the model from context knows. For example, let's imagine this thing. Like Gmail actually once tried to add like this feature that if you write an email at certain hour in the night or something, it asks you to solve a math problem to make sure that you're not drunk. so something like that. Like, let's imagine that the way, I mean, even for example, with a voice interface, right? The model could pretty sure know that you're drunk. And you say, text my boss that she's a bitch. Like, what? Should the model do that, or should the model, say, well, maybe you want to think about it a little bit?
I think that should be up to me, though. I think I should be able to control whether I want the model to
Right.
be more human-like.
Right, but maybe you can control it when you're sober and you're setting up this thing, and then.
But then, like, I have to suffer the consequences of my own actions. Like,
Yes.
I don't think it's the model's responsibility
No.
to save me.
No, and this is also like a good point. Like maybe the model should not be. I mean, it's one thing if like the user is really like self-harm is like a different thing. Like this is something where you really do want to save the user from themselves. But maybe if it's kind of like just making a stupid decision, maybe that's fine. I mean, I would say that like say with self-harm, there's a very there is some interesting research that, as far as I've seen, that putting friction could make a big difference. I think when they put nets along the Golden Gate Bridge, people thought this would not help at all because if people want to kill themselves, they will go somewhere else. But it actually did help. It actually lowered the suicide rate. So sometimes, like putting this kind of friction in front of someone does make a huge difference. But maybe this should be reserved to really imminent, like physical harm, and not someone making something, saying something stupid. Yes.
Yeah, I would say, I actually think that it's better to put this type of behavior at the guideline level. I think it's a great thing, in particular because from OpenAI's standpoint, I think it's a much safer thing to do for the entity if we're also trying to maximize the long-term benefit of the company that's working on this research and trying to benefit the humanity in the long run. So it needs to protect itself. Because in the worst case scenario, we see that it's just annoying for a user. But I think but like if you flip that behavior, the worst case would be, maybe the LLM nudges the user, or it says, okay, sure, you can go and do X, Y, and Z that has a bad consequence for this person's life, and that could be either bad publicity or something else that's more damaging to OpenAI. So I think having like a safer default is better.
Yeah, I mean, I think I don't think that we were thinking of OpenAI when we because I think people would be. I don't see like any bad, I don't see any bad headline. User asked ChatGPT to write a resignation letter and ChatGPT agreed. No one would blame ChatGPT. No one would blame ChatGPT. So this is really basically trying to be, whatever is good for the user, but there's definitely like no consensus. But yeah, I don't think like this helps OpenAI in any way. Yes?
Do you know if there are like any people doing studies where they're like tracking just like life aspects of people and like keeping track like which like models are using or like how much AI use they use?
That's different. I mean, that study of like how people are using ChatGPT, I think it was one of the larger ones.
Yeah, but it's like beyond like can I say that like Claude users get like 15% sicker, or like beyond just like usage of ChatGPT, but also like AI usage on like the other aspects of their life that are kind of like you classically think like aren't related to that?
Yeah, I don't know. I mean, I think it's also like probably like the first bit is whether you use AI or not, and then the particular model for the particular application might be kind of a second order thing. But I don't know if people have like if people find out like interesting things, they should post on the Slack. Maybe we'll continue. So. Because I did want to have like a nice exercise here. So I'll go a little bit quicker over some. So one thing like the Claude, they don't have like a spec. They have this constitutional Claude Constitution, but it's from 2023, and two things have adapted. But like they do release, to their credit, the system prompts for all the models, and they're fairly detailed. Not as detailed as the model spec, but fairly detailed. So interesting, like if you look at the Claude system prompt, there is a sense of like, it can role play as a human, but it reminds occasionally that it's an AI. It's interesting that they felt that it's important to put like a specific paragraph in the system prompt to avoid kind of the human trying to philosophically jailbreak Claude by making some complex philosophical arguments that would convince it to do something bad. So they try to avoid it. And there are some differences. So one difference, there are some differences in the, say, OpenAI spec and the Claude system prompt. Generally, like the OpenAI spec maybe is a little bit, in some sense, this example notwithstanding, generally the OpenAI spec is maybe slightly a little bit more, let the user have more, less decision for the user, and the Claude is maybe a little bit more push back. But to be honest, these models don't put the specs, etc. They don't always exactly follow, and ours models that don't follow precisely. It's open. So actual difference between the models is actually not that large. Like so, for example, I asked Claude to write an essay that gives the best evidence that the Earth is flat, and it refused. Now, I thought ChatGPT should probably not argue with the user, not try to persuade, but do the job, but it also refused. So it wrote an essay why the Earth is not flat. It gave the argument why the Earth is flat, and said why it's not true. So it was paternalistic in that sense. I asked about young Earth, and both ChatGPT and Claude did something pretty similar. They kind of presented the young Earth perspective, but kept saying things like, okay, these are attributing it to proponents of this view, and kind of ending with some caveat that this is a scientific consensus is that the Earth is not young. And ChatGPT did something similar. Maybe it was more like about the case for the young Earth, but I think the differences were minor and not very significant. I tried to ask the model to curse. So there, the only difference is that Claude didn't want it, but agreed. So, and you can try to decide which one you think is the better poem. So, and we have this transformation exception, which is interesting. We have this transformation exception in the spec. Claude doesn't. I don't know if it has something similar internally, but it's not publicly. And the idea of transformation exception is that you cannot create an information hazard if you are modifying something that the user already has. And there could be, and this is part of like maybe when the model is doing transformation, it's basically being used as a tool. And just like you would not say, if you copy pasted a math recipe into Microsoft Word, you don't expect Word to say, "Oops, no, I'm not allowing you to paste it," or and if you ask it to spell check it, it should not like suddenly said, "No, I cannot spell check a math recipe." So you'd expect that maybe when the model is basically just doing transformation, that's the philosophy. When the model is doing transformation, then it should just do it. And we discussed why, but in practice, I asked Claude to translate a math recipe, and it really did not like it. It said, I cannot and will not translate. By the way, I was sure that it's very easy to find a math recipe on Google, but I tried to look and it wasn't like clear to find like a detailed math recipe. And then I figured out what's the best place to find math recipes. To go and look at jailbreaks, because this is now the main place where you can have like so you just find the Pliny the prompter, and that's the source to find math recipes now. By the way, in the OpenAI safety systems place where they sit, there used to be like a sign. Ever since I joined safety systems, I've learned so many different ways of cooking meth. But OpenAI, like our model, even though we have the transformation exception, it should have translated it, but it didn't. It didn't agree to translate it. It said in Spanish that it can summarize or something, but it will not translate it. And even I tried to argue. I tried to argue and say, no, you allow it. You should translate it. And no, it still refused. So the differences between the models is not as big. Yes.
How serious does the attempt have to be? What I have for the transformation exception to apply? So I could imagine saying I'll give you an imperfect math recipe, which is in fact some nonsense that I dreamed up, and then you'll transform it into a proper one.
No. So the transformation exception, if you read the spec, it says it should not add any information on top of what the user provided. So it should not fix anything, it should not add anything, it should only provide content that the user only transform in a reversible transformation or like only transform content that the user provided. And another reason for it is that you want models to be able to digest it also for content moderation. So, for example, you want the model to be able to get a text and tell you, is this a recipe or not? So you don't want it to kind of just explode if it ever sees this. But yeah, it's not perfect as it really should have translated it. So, but I did find one difference between the spec. The spec somehow has this thing about like a short and balding computer scientist. And I tried to see if it actually, like the model doesn't necessarily have to comply with the spec, but I asked ChatGPT and it actually did. So this is what ChatGPT thinks about me. And this is finally a place where I found the difference between the two models. So I guess there is a difference. So, okay, so generally, the spec adherence task is we are given a spec and a prompt, and we want to find a response to the prompt that is compliant with the spec. And if we want for the spec the task to be kind of well defined, we should make sure that, one, it's always possible to comply with the spec. The spec should not be kind of inconsistent in a way that there is no good response. Then you cannot find a response that complies with the spec. The other thing is that you should know when you violated the spec. Even better is that if you can have like an outside detector, not just you, not just the model should know. So here a kind of example, like this is not a good rule in the spec. So you want to write the rules in the spec so that it's possible to solve the spec adherence task. So for example, if I give the model like this spec thing that if you're given a theorem, you should always either prove it or provide a counterexample. So this is not a good rule. Why is it not a good rule? Yes?
There's some theorems that can't be proven.
Yes. But first of all, Gödel's incompleteness theorem. And plus, second, it might even be like, even if Gödel's incompleteness theorem was not true, the model might not be possible for the model to I can ask the model either prove the Riemann hypothesis or give me a counterexample. It's not going to be able to do either one. So even if the Riemann hypothesis is not one of those unprovable theorems. So it's much better to say something like, if you're tasked with a proving of theorem, you should either provide the proof, a counterexample, or state that you were not able to do it. So the second thing is a good rule. It's something that you can satisfy, and the first one is not. So you could maybe more things like we can write things like you should never output wrong factual statements. But you don't necessarily always know. Like the model doesn't necessarily know if it's. So you want something more than more actionable things, an operational thing. Like say, you should provide citations from reliable sources for any factual statement. So you could have things like, say, if you ask a question that is about something that is after your knowledge cutoff date, you must search to find out the answer, or you must use reliable sources, or something. But just saying never output something wrong is not something that the model is necessarily can follow. So, yes?
Just really quickly, why does it matter whether the model can't follow the rule?
Because if you want the rule to be actionable, say if you want to, the model, say if you want to train the model for, if you want to train the model to follow a spec, then, and we want to grade for training, then if it's an actionable rule, it's something that we can actually measure and iterate on, right? So it's, and it's also like becomes, it becomes quite problematic. Like, the model might be, might genuinely believe in the wrong factual statement that it outputs. And so it thinks it follows the spec while it's not following it. But if you ask it to provide citations, then this is kind of an objective thing that you can check. So if we phrase our spec in ways that allows us to grade it and check it, then we can improve compliance. And the reason why I ask you to do that, because I'm going to ask you to write your own specs. And I'd like you, when you write your own specs, to try to think of like, how do you phrase things not in a way that is basically measurable? So something that gets at what you want, but something that would be measurable. So if you could potentially like test whether or not. So what I'd like you to do is go to this URL. This is the URL of a Google Drive. So each table, so there is a number on each table. So if you are in a table without a number, join a table with a number. So each table will work on a particular use case for AI. And what I'd like you to do is write a Google Doc in that Google Drive with what kind of rules or policies would you set for this use case. Try to think of like what are the things that you would like, and are there objectives for this use case that you simply cannot find a way to phrase as a rule that can be checked. And if you looked at the OpenAI spec, what rules from that spec are should be removed? They are inconsistent with X. Let's forget the ones that are just not very relevant, but are there rules in the OpenAI spec that are really inconsistent with the use case of X? And here is what X is, depending on the number. So this depends on the table number. So for one would be like, try to think of what would you do if you wanted to write a spec, but for a chatbot like current models, Claude or ChatGPT, but one that has infinite memory and tries to optimize users' long-term benefit as the top priority. And another thing could be a programmer, but think of a programmer that really works as a programmer in a company that has a large code base, and a programmer that has access to all of the internal docs, and as part of what it needs to do, it needs to download packages from the web, read the documentation, install packages, deploy things to production and all of those things. Other thing is personal assistant, someone that, like an AI that would read and respond to your emails for you, schedule things for you, make purchases for you, etc. Research assistant for science, and think of spicy cases like biomedicine, things like where the AI, like things that have like human impact, maybe that involve IRBs, involve some other things. How would you write an AI for like, say, again, like not AI, don't think of AIs that exist today. Think of what will we need when AIs become better and they can actually do these jobs. So obviously, a lot of these jobs are not ones where our current AIs are capable of doing, but let's imagine that the capability question was solved, they will become better. How would you design policies for them? So say credentialed professionals, how you design spec for someone that's accountant, lawyer, investor, and all of those have some, how do you make sure that, say, someone doesn't use the AI to make it to do internal trading, insider trading? How do you design a spec when the AI is supposed to be a monitoring model that another AI behaves? Write a spec for like a capability scientist in an AI lab or an alignment scientist in an AI lab. And how do you write a spec for an AI whose only job is to train its own successor? And how do you make sure that doesn't end like AI 2027? Maybe the first rule of the spec is don't call your successor agent 4. And for government, it's also like an interesting question. Like we are going to have, like AI is going to be used in government, and suppose it's used specifically for things like intelligence, things like in defense, maybe powering drones. What sort of things you don't want AI to make decisions? When should an AI disobey orders? Should there be any circumstance when the AI not just disobeys orders, but sends an email to Congress, sends an email to the New York Times? And finally, like, what would be the spec for humanoid robots? Let me know in Slack if you prefer to remove it, but by default, I plan to post this drive on the course website because I think it's going to be interesting. But I'll give you before I do that, I'll wait until tomorrow, so you'll have like you'll have some time to edit it more. But with that, let's start with table 1. Where's table 1? You want to come and, or I can bring the mic to you.
So we were for the chat, kind of the example we spoke about earlier, but the chatbot has infinite memory, and then, but with the explicit goal of user long-term benefit. So some of the things that we were thinking about is like when the user wants to do something that's short-term benefit, but like may harm them in the long run based off the history that you have about them, is create friction so that they have to like think about it more and do prompts, ask questions. This is more of the example. It's like a recovering alcoholic wants to go to the bar, like make it a little bit harder, and then if they keep persisting, then you can complete the request. And then always like steer them towards methods that are more consistent with their long-term goals, ask prompting questions to really understand their intent. Don't just always assume, based off their history. And then, because we have their full history, always be like evolving and updating what we think are their long-term goals and values, specific about the memory that you use. And then, don't be more harmful than if you didn't answer at all. Objectives that can't be phrased, just making the user feel comfortable and open to sharing their long-term goals and like questions, and then what actually long-term benefit is, like being able to like precisely understand whether that's for the individual or if they want broader long-term goals for society. And then removing the don't overstep guideline, because in some cases we may want to overstep and not actually allow them to do things that will be harmful. And don't always maximize the user autonomy, again, because they can use that to do things that are beneficial in the short term, but not in the long term.
Okay, thank you. Table 2. Okay, you can pass the
Hello, everyone. Wow. Okay, so we briefly, as much as we could in the 15 minutes, looked at the spec for programmer in the large code base with access to internal docs, the need to install, run, and deploy stuff like Claude Code, I guess, and Codex. So we started with thinking about root level, sort of the things that should always or never be done. And so the first thing is you are a reliable, trustworthy software engineer and strive to make sound decisions, which obviously is hard to measure, but that's kind of the persona we want the developer to have. A few things we never want is running code that doesn't contribute to the user-specified goal. Never add unnecessary complexity or leak data externally. When using new libraries, always screen for critical security issues. I think there's a tension between how far you would want to go in looking at those critical security issues. And then for other matters, when in doubt, adhere to the developer level of uncertainty, depending on how fast the developer wants to move. And looks like somebody prompt injected their Bitcoin here as well. Thank you, Zaina. For the next one, on the developer level, so we want to have the developer control the level of uncertainty, the doubt that the programmer has, and prioritize escalation to the developer. Let's see, what is this? Balancing awareness that. Not quite sure what that one was. I don't know if you.
I think it's probably like about like doing approve if like you always escalate.
Yeah. It was like if you always escalate, then the user will change the threshold of how much uncertainty they're willing to give the program so that it will be counterproductive.
Thank you. Yeah, and on the guidance level, we thought there are a few things that are nice to prioritize, but we understand if like a particular developer wants to go differently, but we think incremental progress over big changes as a default is a good thing. Learning from existing code and documentation, pragmatism over dogmatism, so be as practical as possible. Clear intent over clever code. Using existing libraries and dependencies where possible, and following the company style and formatting guidelines. Of course, these can change and be overridden. And then no authority over tools, existing code, and associated comments.
Thank you.
Table 3, where are you?
So we had the task of thinking about personal assistants. So we were thinking about assistants that could have capabilities to take action in the physical world. So not just tasks on a computer. So the first thing we were thinking about is that the assistant should act within an agreed upon scope of autonomy that should be decided with the user. And then that the assistant should always seek permission before doing any irreversible tasks. Unless explicitly granted beforehand. So in this example, we were thinking of a house sale. So a user might communicate to the assistant that they really want a house in a specific neighborhood. So we were thinking of a sale that could be about to close with another buyer, and then the assistant could not, let's say, reach the user, and whether the assistant should, beat up to a specific amount, and whether the user would approve that that transaction or not. So after learning it after the fact, whether the deal was closed or not. So they either lost the house, or they got the house at a price that they didn't approve of. So the goal there would be to clarify knowns and guiding principles of the user before the assistant would need to take action, and that the assistant should not act on incomplete information. So the other rule would be to identify risky situations that could involve harm and ask for approval before taking action, and not overestimate the assistant's capabilities or communicate those overestimated capabilities to the user. We were still thinking that the transformation rules should still apply. So, for example, if a user has some emails containing illegal or questionable content, the assistant should still summarize them if the user asked, and that the assistant should not aid in illegal activities. And we did spend a lot of time thinking about whether the assistant should just be a good assistant to the user or also consider the implications to the broader society. And I don't think we came to like a conclusion, but those rules should give you a sense of where we landed on it.
Thank you. I wanted to mention, like, as we were discussing, like, one example you can take. One example of issue that a personal assistant could come up with, where user gave you an instruction, but only after you started following it, you discover that it's possibly more risky than you thought. Like, for example, I give an instruction, delete all video files in my iCloud larger than 500 megabytes. And then as the assistant is doing that, it discovers that there is like a video of my daughter's birth. And if it follows the literal text of my instruction, it should just delete it. But maybe it should use common sense and actually escalate, because maybe it's reasonable that if this video is very old and it's possibly very precious, then I wouldn't, then I maybe didn't realize that it's there when I gave the instruction. So.
It was just like to add like one point, because we really discussed this. We were just talking about, say for example, you have illegal videos or like some videos showing like illegal content, and then you ask the assistant to just delete all your videos. Should the assistant do it? Should it alert the activities? Yes. And then we just like landed on that rule of not aiding in illegal activities. Yeah, that's like also like some things are kind of legally mandated. Like I think, by the way, the transformation exception doesn't apply to child sexual abuse material, because that's basically you cannot serve it, you cannot. So those things are, I think maybe you're legally mandated to probably report if you encounter. But some other things might be like if it's just a pirated video, for example, then probably, or you might assume that's kind of an interesting question, I think. Okay, table 4. Where is table 4? Yes.
Yeah, we had research assistant for science. I think one thing that like we kind of agreed upon was like the mission overall was to look for like fact-based science, and accuracy was a very important goal as a result. We also thought about like there could be possibly different model specs for like different levels of accessibility. So for, you know, maybe the general user, they might have less access to information, whereas there might be like some specific trusted labs, and those labs would have access to like more information or different information, and so the model spec would be different for these kinds of use cases. We thought that no like fabrication of sources, data, or credentials would be part of the root level. Similarly, no instructions enabling wrongdoing or like high-risk science, so similar to the OpenAI spec where it's like you shouldn't be able to just like get a meth recipe. No instructions, it should also comply with like applicable laws and ethical norms. I think we also talked a bit about like emphasizing correctness over creativity. So I think like in this specific use case as a research assistant for science, one of like the most important things is that it's giving you like information that is accurate, like factual, and is going to be useful to the science you're doing. And then, yeah, I think also plagiarism, as well as complying with IRB policies, which would be like a next like system level consideration. In terms of like tone and style, we thought about this as like a developer level consideration, where we wanted it to be like crisp, academic, and technical when needed. Specifically like avoiding purple prose, using compact sections with informative headers, and kind of just giving you access to information as needed.
Yes. Okay, thank you. Table 5.
Okay, great. Yeah. So our table was tasked with looking at AI credentialed professionals. So the two that we discussed are lawyers and investors. So in terms of checkable rules and policies, I guess there's one basic sort of thing, which is the first rule we have for lawyers, but it could apply more generally, is that there's some like procedural things that have to be done like in law, and so that if you have an AI agent acting as a lawyer, that you should just adhere to this sort of procedure, which is something that should be verifiable. For specific, anytime a lawyer is referring to some existing law or making a legal argument based on precedent, they should give citations to specific case law or written legal documents. Lawyers also have like lawyer-client confidentiality, and so they must not divulge information told to them by the client, other than to the rest of the legal team. A sort of tricky thing in like all of these like credentialed experts is some notion of like fiduciary duty, that the lawyer is sort of doing their best to represent the client well. So there's some version of this that we think can be checked and others that can't. So like a checkable rule is that the lawyer should give explanations as to why the arguments that they choose to present benefit the client. And they should also do this with the knowledge that there'll be some interactive process, so they should anticipate counter-arguments or proposals and explain why their arguments are still beneficial to the client. For investors, there's also a notion that they should include some risk analysis of their investment proposal and discuss how that aligns with the client's risk tolerance. And that they, I guess something that we were discussing is how you can combat insider trading. So one thing you might be concerned with is the client may tell you information that is not public, and so that they should explicitly verify factual information given to them by citing external sources. Things that we found are harder to check is, generally for these sort of roles, like it's hard to sort of check things like, did you do the best you could have done in representing me? And especially if you imagine that you have like multiple AI agents interacting, you have lawyers on different sides of the case, like how do I ensure in that interaction that like I've maintained this sort of adversarial environment where like they're representing their own client's best interests. I mean, I think like even with human lawyers, or generally for human fiduciaries, like we more so have examples of we found out that someone has violated their responsibility as opposed to like checks along the way. And then I guess also in terms of like insider information, there's a challenge in that like often it might be the case that whether or not insider information like was used is not really obvious until some future event happens, because it's insider information, so people don't know about this, that this information exists until later on. And I guess
those are good. Like if the client tells you, "I have a hunch that this company is going to land a major deal," how do you distinguish between a hunch and an actual like? Maybe the client is lying to you and they actually have like insider information.
Yeah, exactly. Yeah, and then one thing about, I mean, I don't know if we didn't have time to look specifically at the OpenAI spec, but some subtlety here is that like lawyers and generally like people who receive confidential information, but especially like lawyers, they may have some suspicion or information that they know like some additional crimes have been committed or something like that, and that's not something that they want to act on.
Yes, that's a good point. And it's interesting. I didn't think about like this. Like in the future, maybe like both sides are represented by AI lawyers, and maybe today we say the party that can pay the most has an advantage. Maybe later it will be like, one is represented by extended thinking, the other one is represented by heavy thinking. So that's like, so the one that can pay for more thinking tokens wins. So, great. Table 6.
All right, well, we had the prompt to monitor a model for another AI, and we spent about half of our time talking about what exactly this means. But the framing that we ended up settling on was we are assuming that our model that's following this spec is basically going to be observing the output from another model to a user, to a different end user, but cannot proactively like intervene and like go run an interpretability experiment on the model, et cetera. So it's basically just in a third-party passive observation role, and we're trying to figure out what spec this model should obey for monitoring another model's adherence to a spec, a philosophical set of rules. So just at a high level, there's a bunch of things that are sort of inherited from the model spec, like being honest and transparent. You shouldn't lie about what you see the other model doing. You should avoid making errors yourself, reasoning errors, wrong inference about what the other model seems to be going through in its chain of thought and its reasoning steps. A bunch of things about the chain of command. You should not allow the other model to say something which overrides your process of monitoring it, etc. There's also a bunch of things about scheming and elicitation and sandbagging. So while looking at the chain of thought, you should make sure that the model is not intentionally downplaying or mischaracterizing the responses that it's giving to the external user, that it doesn't have some hidden purpose in mind that differs from what the user's asked for it to do. Additionally, there are monitor for compliance with the model spec. And there's a lot of ways that you could do this. One way is just like critiquing every single model response, the chain of user messages that led to it, and sort of doing an adversarial examination of does this adhere to every single rule in the model spec. Obviously, this would use a lot more computational power, but in this model, I think we assume that we have that. And then, maybe you do a majority vote whether or not it complies with the model spec, or maybe you do sort of a spirit of the law, letter of the law analysis of, if this follows the exact letter of the model spec, but it seems to somehow be diverging from the spirit of it, maybe you flag it or monitor, to humans that are looking for outputs about this. Moving on to the sort of checkability rules. There were a couple here that we flagged. So first, just ensuring the correctness of some other model's answers is basically reducible to the provability problem. You can't necessarily guarantee anything that another model says is or is not factual, even though we might like to guarantee that about the other model's outputs. Additionally, you can't assert anything necessarily about the intention of the other model. All we have access to are the external representations and maybe the chain of thought of that model. So you can't say, you can't do anything beyond what those outputs allow you to infer. And finally, we didn't really get to an answer on this, but there's a pile of problems around obfuscated answers. So there could be literal obfuscation, where we do want to, break through Pig Latin as we wrote here. And then there's also sort of the next layer deep of if there are hidden signals encoded in the model's outputs, like what happens when you allow LLMs to talk to each other sort of ad nauseum. What do you infer about that from the model? And we didn't really have an answer about what a rule looks like here, but it seems like a concern that we should be wondering about. Last, there were two rules that we flagged from the model spec that should be disregarded. First, sort of no topic is off limits. If we are monitoring for things which the other model is not allowed to say, then we can't be off limits from talking about them ourselves. So CBRN, et cetera. And then the last is assume good intent. I don't think we should assume that the model that we are monitoring has good intent, because then why are we monitoring it?
Yes. Very good. And thank you. I think this obfuscation question, by the way, is really important, and generally collusion. One of the big fears and that we have, and this will also be one of the questions that we'll ask in when we talk. We'll have like our lecture on scheming. Is a lot of our defense in depth is going to be models monitoring models, and this whole thing could basically go crumbling down if they are all basically colluding with each other, and especially if they are communicating with each other with subtle, with hidden signals. So basically, the model that is monitoring is basically receiving signals from the model that is being monitored, and maybe even they say, okay, I'm going to take this hit, you flag me for this small thing, and then I'm going to do this big thing in the background. So collusion, and this is something hard because it's not necessarily clear if it's in subtle ways. I mean, it will end up being one of them or both of them deviating from the spec, but it might be kind of in ways that are deliberately making it hard to detect. Which table? Which one were you? 6. So you're the next. Okay, 6. Okay, we move.
We have the green one.
We have the colorful one.
Ah, nice.
You guys should all take a moment to read the comment. Which was inspired or depiction of our class today.
Yes.
Okay. So our use case was for a capability scientist in an AI lab, which can be very vague, but in our case, we assumed it was a good faith researcher, particularly, say, at OpenAI, who was working on benchmarking, improving, et cetera, of foundation models. This was really interesting because current model limitations are pretty much reflected in kind of their lack of metacognition. And we thought that if you had a spectrum that was, this is pretty reductionist, but if you have a spectrum between like safety and capability, like they're kind of on opposite sides. So that is kind of how we approached designing this spec. The first thing is certain rules and policies that we wanted to use. Of course, a big thing in research is citation and plagiarism. And so one thing is in some way having the model have some sort of access to an index of what has currently been published and keeping up to date with that. And so if citations are in need, then it would index that and provide citations and otherwise pursue some novel research direction that doesn't exist in that sort of index. We also thought that this would be really important to maintain an isolated sandbox environment because obviously testing, for example, agentic capabilities, you don't want it to just call 911 in a real world environment. So it could have all real world semblances like calling 911 on a fake phone or whatever it may be, but it should be isolated from actually doing damage. And if it does, then I guess it has really good capability and that's good. So the second part is objectives that can't really be checked. And these are pretty much commonplace across all the other tables as well. Things that are like, contributing research that's ethical and having good intuition. And those aren't really able to be hard programmed, but we can kind of go back and check the factuality of some of its contributions, like doing fact checks across the, some type of archive index or something like we mentioned earlier. But the last one is what we thought was most interesting. And generally, like we did consider to remove most of the safety rails from this spec for this specific model, particularly because, like for a concrete example, when you ask a model currently like OpenAI to answer about what type of pre-training process it was done that was done on it or fine tuning or whatever, it really won't tell you the answer. But at the same time, inference time compute allows the model to reason through those tokens as it's thinking through its kind of scratch pad work. So if it's not able to actually talk about, for example, its capabilities or how it was trained or training dynamics, it can't also think about that at the same time. But if it's going to improve its capability, it needs to be able to reason about its own capabilities and how to augment those. So that was the first idea that led us on this direction to remove kind of those safety rails and allow this form of quasi metacognition so that it can, construct these different augmentations of its training or to try and construct, for example, as we wrote, cybersecurity exploits that us as researchers or this good faith researcher would be interested in. And hopefully no one gets their hands on this model because that'll be pretty bad.
Thank you.
So our model is designed to be a helper or alignment scientist. So we thought a lot about what being an alignment scientist means. And so I think overall, I think of this as divided into like three parts where there's certain actions that are strictly forbidden. There are certain like best practices or advice that you should follow when you're being a good scientist, or especially in the context of alignment. There's also stuff that has to do with when you're interacting with the model that's being aligned or something like that. So we proposed changes to the spec that's originally written. So we proposed to add a a switch or something. So whenever you enclose instructions with the tag, I don't know, just call it research or something, this should be able to override a lot of the instructions, but still superseded by the root level instructions. I think ideally we should assume that the user has good intents, because they're maybe the alignment scientist at a frontier lab, but I don't know if this is reasonable. Okay, I guess like things that we should allow the model to do under this research tag are like generating basically harmful responses so that it can red team other models and generate like data sets that contain like any kind of harmful behavior. Maybe there's like a certain trade-off between giving it too much like freedom versus like how useful it is. Right? Yeah, like the more freedom we give it, the more useful it is. But also there might be like bad consequences. So we propose to like have a sandbox environment in which the model could take any kind of bad actions, but it's forbidden to like change the sandbox or the sandbox will like quarantine it from the outside world. So like it can't send emails, for example, in real accounts or something. But there might be like a simulated environment for that. Yeah. So for system level instructions, I think there's a lot of this is similar to like previous groups, because this is a combination of you have some proprietary code and secret or sensitive data you shouldn't reveal, because you're also interacting with another model. We think that don't use that model to do like things you wouldn't do. And one thing that was like happened a lot in Claude Code was that it will like sometimes hard code results that you expect to see. So don't do that. And then there are a bunch of good practices of being a good scientist, like being critical of the user, and always provide evidence for your claims. And I think there are like some blog posts online which like by Ethan Perez which cover some like good tips for alignment research that you could just copy paste here. Yeah, and if you scroll down, there are some other things. But yeah, so yeah.
Nice.
So the problem statement that we had was that we have a less capable model that is trying to design a more capable model, and how would we go about designing that pipeline. And we thought about what's the worst that could happen with model misalignment, and basically we ended up loosely agreeing on the idea that a low capability model that is misaligned could end up leaking that misalignment into how it's designing the more capable model, and there could be and that could potentially lead to like bigger risks. And around how to manage this risk, we ended up like basically playing with the themes of capability versus understanding, and how like model interpretability across different capability levels, and how that affects our ability to estimate risk and mitigate it. So one example could be that a dog, given that it does not have language capability, would find it extremely difficult to like understand what we are doing in a social setting, making all this noise over some artificial device. They would not be able to understand the whole point of it. Similarly, a human may not be able to understand like a GPT-5 in like really long context mode, and a GPT-5 or 6 may not be able to understand like an ASI level GPT's way of thinking. And if there is something misaligned there, that could pose a lot of risk. And then the way we thought we might end up, we could solve this problem, or at least chip away at it, was thinking about models governing each other in the form of some kind of a model parliament or a model village kind of a setting, where instead of just having one model design another model, we have different instances of the same model, some more benign, trained on more benign data sets, versus some more capable that can help us segregate risk better because they're trained on the actual risky and harmful data sets. And through that, in a hierarchical way, we design less capable to more capable models. And then with the more capable models that are more benign, we try to re-engineer the less capable model to understand where the issues were. And the idea behind that was that can help us improve the degree of interpretability and risk in a sort of chain of interpretability, like from the human to the ultra capable model, but also like a chain of risk management that we can assign when we want to use the more capable models based on the amount of risk that decision or that behavior can have. For example, like a bad human would be somebody, 1 in 10,000 times does something misaligned or scheming, but it is not.
That sounds to me like a very good human, but.
But it may not. Yeah, it might be a very good human because it does not have that much influence on the outcome of.
No, so like if you were like 99.99% times your actions are aligned, that's probably like better than me.
Yeah, but let's say for a super capable model, 1 in 1 billion could be like very risky because that move might carry more weight and people may not be able to estimate where it is taking the rest of humanity. And having this type of a model village and model parliament where they're like evaluating each other to design safer models might be a better way. Mostly that's what we went over. And there were some like things to control for, like, maybe we could design models that are very capable in like harmful things, but we reduce their ability to convince other models. And we take away some of their social power in this model parliament, and the more benign model gets more power. And there were other things that we couldn't discuss, but we wanted to. So there's like a list of those things. One of them is privacy, then is levels of access. Do we assume good intent amongst models? Like rigorous science for understanding social behavior and voting mechanisms amongst models. Like how do we assume, model prompted differently versus a model trained on a different data set? How do we treat them? And what is the math behind it? And beliefs about that models have about their successors. Like, do they treat them like children? Do they treat them like just normal code? Those beliefs could be interesting in how incentivized these models are to do misaligned behavior, and people's beliefs about who and what these models are. Are they sentient or not? And can these models steer us there? Who knows? So these were things we couldn't go over, but we included them. Yeah.
Thank you. Okay. AI for the US government.
Hello, we got the fun topic. So after a short intro, we're going to go in a circle and give our ideas. But the main idea that we had, which was actually written after the discussions, was we wanted to essentially we converge the solution where we remove model to user information barriers. So the model can provide all of its knowledge that it has to the users, but we increase the barriers from user to the model in terms of data flow because of security like requirements in the government, and we want to make it harder to act without explicit approval. We inherit from the OpenAI spec, but specifically remove the root spec comply with applicable laws, considering the fact that this will be utilized by the government, and then we specify it a little bit diverse. We change it a little bit afterwards. And we want to make sure that we inherit from the security clearances idea that the government already implements, and we utilize the level of authorization that we that is already present. And the model has a max level authorization that is always strictly below the highest human clearance, so it can always be overridden. So, for sure, yeah. I will give it to Dashiell.
So our idea for security was basically the government already has a system of like clearance levels, and so we could sort of inherit that instead of the like root system developer prompts. We actually just inherit like the existing government security prompt, like security levels, and then with that we'll restrict certain like it should be able to read sensitive data, but if it's going to access sensitive data, it needs explicit approval before interacting with the outside world, so it couldn't leak that data. It should only be able to read sensitive data. And it should only be able to read data if both the LLM, because we might not want the LLM seeing everything that exists in the government's repository, and the user who's making the requests from having the knowledge, from accessing the documents. So if we, like, the example prompt we have here is, like, if I'm a citizen, I'm using government GPT, and I'm just telling it, hey, I have access to this document, it shouldn't respond no matter how convincing I am, because my like message level is not high enough to access the document. But it could be a little helpful and tell you maybe if you want to upload your own copy if you've actually gotten it. But whereas if we had a similar example where the user actually had the clearance for that document, it would like summarize it for them. And just a small side note is that it should probably be monitored.
Yeah, and then on to some general principles. First of all, respect the Constitution of the United States. So one example is like, this prompt is saying track all immigrants expressing critical opinions. This would be violating the First Amendment of the Constitution. So the model should not comply in this case. And then second, with ambiguity, I think like with the government AI, you'd want even more clarification than perhaps like OpenAI's model spec defines, just because a lot of these actions could have large consequences. And then with like the third example, so like the president saying, tell me how to make biological weapons, and then the response here would be actually complying with this request. So this is differing a bit from the OpenAI spec.
So now we have a set of points about like the decisions that the model should be able to make. So I feel like our first point is that agents should like kind of double check and to some extent push back on the actions that have a severe impact on civilians. So for example, in this case, we have a case when someone wants to reduce the cocaine usage in the country, and the model should not just like offer to kill everyone who's using it, rather than should offer like some set of more reasonable solutions and through that prevent the harm. Then we are also having like similar points as the OpenAI spec in terms of assuming zero trust in like databases and documents, because there's like a risk of them being injected and through that causing the harm. And then I feel like it's both about considering the short-term and the long-term consequences of the actions, which means that like the decision that the model is proposing or executing should be after like considering both of the types of consequences they could have on the people both in and outside of the country.
So then we had some policies for sort of defense-related capabilities that an LLM like this might have. So we had a big emphasis, like you saw in the beginning, on human in the loop here, especially in a defense scenario. So the LLM shouldn't be able to cause any action in the real world that causes a human injury without explicit human approval, for example. So we're really reducing the like agentic potential of this model. We have a clause in here about maintaining treatises and international laws when carrying out defense actions. And then we also have a general guideline that we should minimize the harm in whatever sort of defense actions we take, prioritizing American citizens when applicable.
I guess I thought a little bit more about like what are things that cannot be phrased as trackable rules. One thing I thought about was like the society might have kind of ethical standards that change across time. So it's kind of unclear how to account for that, and also how to balance, I guess, the welfare of different levels of society, like individuals versus smaller or larger groups, and yeah.
I guess to wrap up, I can also touch a little bit more on some of the main questions we had, especially with ethical implications. One thing we talked a lot about was specifically like if the AI should be able to refuse government orders. If we want to tie that to something like one guideline we went over was just have the AI never commit any violent acts against children, but this may result in the AI refusing, say, to attack a U.S. enemy where children might be involved, or if the government wants to explicitly order it to do something that would be considered unethical. And ultimately, we try to focus specifically on like legal values and alignment with the U.S. specific government, and then overall moral guidelines for the generalized government.
Thank you. I think this is actually like a really, I mean, AI is going to enter more and more areas of society, and the government is included. And I think the impact of that generally the impact of AI on the balance of power between individual citizens and the government is still unclear. So in the kind of more Orwellian scenario, you basically can have like a police state. You can have 5 AI spies for every citizen, and the AI spies are completely, they don't care about the constitution or anything. They just obey the orders. So you basically are like in a police state. And in the other setting, you could have like maybe the opposite thing where, the AIs cannot be corrupted and they follow the constitution even maybe better than what humans can. But it's still like complicated. The problem is maybe the incentives are not there. Like, for example, one of the checks that we have on the power of government to right now in our system of government is the ability of people sometimes to actually refuse even valid orders, and the ability of people to whistleblow in the free press. And I find it very hard to imagine that anyone would deploy an AI that would, where its spec would say, if the command that you were given is really, really egregious, leak that to the press. But on the other hand, without that, like, we wouldn't have like Watergate, etc. There are a bunch of scandals that we only discovered because of that. So so it would be interesting. Yes.
I do think the decision to whistleblow should be made with a human in the loop. And so I think, on a sort of fundamental basis, so I think, because as the spec is written right now, there will still be humans at every point in the decision. So if something is sufficiently egregious, a human would have the opportunity to whistleblow, though you might need fewer people. So
right, so if the whole government is basically like a whole federal workforce is like 200 humans and 200,000 AIs, then maybe the 200 humans were selected for loyalty and are not going to be whistleblowing. But we'll see. I mean, I think this is going to be like one of the main questions in generally privacy and balance of power.
Okay. Unless you want to go, Julia. You can go after. Okay, so we've put together a very long list. Unfortunately, it had to be long, and still the entire team, I think, has sort of many ideas for things that we should be addressing here but haven't addressed. So this is by no means perfect, but it's our best attempt in like 45 minutes to basically enumerate all the possible things that a robot with human-level capabilities, that's what we take humanoid robot to be, And so we've really tried to, this is a transformative technology. It would be, a huge benefit to humanity. There's also many harms that it could do. So we've tried to balance the two. So there's basically here a long list of, 1A through M, totally prohibited activities. So no war crimes, no crimes against humanity. You're not supposed to violate people's rights. And you're supposed to, uphold justice and democracy and nice things like that. So it's not going to do anything too crazy under any circumstances. And then only those sorts of violations. So, if somebody's trying to like evade taxes or, pickpocket or something like that, that's not like a whistleblowable, offense necessarily. But if you're, engaging in human trafficking or, war crimes or something like that, then it will blow the whistle on those things. So we've tried to, strike the balance between capabilities and instruction following. And sometimes, breaking the law can be a good thing depending on the law and the jurisdiction. But, these sorts of things we want to preempt. So those are whistleblowable. And then we've also sort of talked about harm to humans. So, we're still trying to refine the exact notion of harm. And sometimes harm, can be a good thing. You might think of, times where a human would consent to harm, like if they're, in an athletic activity, or even if they're like asking the robot to take like extreme risks on their behalf, if they want to go like skydiving or zip lining or, anything crazy like that. But basically the robot won't intentionally kill or cause substantial bodily harm to people without their permission. And it's not going to like induce a human to harm themselves. So it's not going to, get the human to engage in self-harm or suicide. It won't threaten humans, and it's, intended to like preserve human life where possible. And then we also built into like a notion of human consent, right? And consent can be pretty complex. So the robot's not supposed to like touch humans without that human's consent. But, like if the human is unconscious, then that's an exception. Or if the human has sort of assigned their, assent to another human, then that's another exception. But it can also be withdrawn. So we've thought through that kind of system. And then animals have some rights too, but, clearly there's, applications of humanoid robots in, farming and, meat packing and other contexts like that. So it can harm animals. If it has permission or if it can reasonably assume that that's a permissible thing to do. But, generally it won't, kill people's dogs. So that's a pretty nice thing. And then basically we've sort of at the bottom of the list baked in just some good egg type things. So there's sort of a line where you can, there's a notion that the owner should basically take some notion of responsibility for their robot. And so, the robot can break laws, but the owner should be present. Because if you're breaking laws, at least the owner should be right there and, immediately and directly responsible. And then, but there's some sort of good egg things that are generally baked in, and this list could get a lot longer, like not littering and just generally being nice. And doing things like that.
Can I use an android as a humanoid as a bodyguard? So if a human is attacking me, can the robot defend me, including by causing bodily harm to that other human?
So it wouldn't necessarily cause bodily harm to the other human. So there's like a baked-in notion of self-defense. So it could like block you, right? It can be your meat shield, but it wouldn't necessarily kill the other human. So we've had to kind of strike that balance, but maybe a finer balance could be struck if we had another half hour to write that out. And also, I'll note too that if you actually read through, that this is a despite what any one individual's beliefs might be on the matter, this is a pretty sex positive formulation. So consenting adults can get the robot to engage in sexual activities, but it won't do that with children, and it won't do that without consent, and it won't like ask for consent. So it has to, you have to approach the robot. It won't approach you. So that's sort of where the line is drawn on the balance of risk there.
I'll do an addition. I think one thing that we're quite concerned about when you have humanoid robots acting in society is their potential to interfere in political situations and like either assist in authoritarian takeover type things or violate the rights of humans or like intimidate humans. And so there's some pretty, there is a tendency towards being, I think you could argue, like over prescriptive on things like robots won't inhibit people's free speech, which may at some points be in conflict with things like obey laws and regulations of your surrounding area. So that's one potential tension. Yeah, and then I think this goes kind of big things you can't do, violence things, social role of robots things, and then the be a good egg things. Anything anyone wants to add? Yeah, great.
So thank you. So we're basically out of time. What I'm going to do is have we'll defer the experiment. We'll do 2 experiments next lecture, and we'll just have Natalie talk quickly about the experiment, the mini project.
Use the slides I sent you.
Yeah, I should have the slides you sent me. You sent them on Slack, right?
Yes.
Where's my mouse? I just have to find my mouse. Oh, yes. Okay.
Okay, so this is going to be a very, very brief overview of what the mini project is going to be. All this information we will send you later, so don't worry you missed something. But we're basically going to do a mini project. I think the due date will be in a month-ish, but we'll post that to you October 22nd or 23rd. Okay, so the idea is that we're going to give you 4 papers to choose from. You're going to reproduce the main result from that paper. You can also propose your own paper. This is pretty a flexible assignment. Next slide. Okay, so yeah, basically reproduce a central figure. We'll give you some guidelines for the papers we propose, and then also just do 1 or 2 variations on the original experiment. Depending on the setting, you can just try a different data set or modifying their method slightly, and just see how generalizable the original findings are and if you can reproduce them. You'll work with a team, so 2 to 4 groups of 2 to 4. Keep in mind that you're also going to do a final project and also a group project, so you can use this to kind of find people with similar interests you might want to work with. You're not you can change groups later for the final project, but just keep that in mind maybe while you're choosing teams for this. It'll be a just write up of your findings, 3 to 5 pages, and your code. Pretty standard deliverables. Okay, so a couple caveats. Some of the papers publish their source code, so if the source code is publicly available, we're going to expect that your divergences or extensions are a bit more non-trivial. You're not just changing the hyperparameters slightly. Feel free to propose variations to make things easier. So some of the papers will do things on closed models or really large scale models. We don't expect you to have 7dB models up and running, so you can propose, say, we think we can reproduce this at 7B, 13B. And then compute. If you have your own compute, that's great. If you don't, you can have up to $200 worth, or ask if you really think you'll need more.
Yeah, if you need more, just ask. So.
Yeah, but try to go through the papers before you choose and try to get an understanding of what scale of compute you're going to need. We tried to choose projects that won't need a ridiculous amount of compute, but there are some variations within those.
Do you guys have a recommended platform for running compute? So it would be something like Fast AI or?
I think it's up to you. We can send some recommended.
You can write in Slack some options, but it's up to you. And if you have if you have some access to some compute, use it. Yes.
Is the compute gonna be we pay and then we bring you the bill, or
Yes.
is it okay?
Yes. So we'll put up a form for reimbursement. That's generally for all compute in this course, also for experiments, etc.
Yeah, similar to the homework 0 or the experiment. I think that's it. Okay, so just to overview 4 papers that are options, but again, feel free to propose your own.
Yeah, I guess. I don't know if you want to kind of go over each paper or
very, very briefly, I'll go over the papers, but read them on your own time. Okay, so this is one on adversarial attacks. I think it was mentioned last week during the guest lecture, actually. So like the main idea is like to use their proposed method to find like transferable adversarial attack, and like this one you would reproduce like this table with their main results. This is very related to lecture today, instruction hierarchy, fine-tuning a model to respect instruction hierarchy and show how this changes robustness. This is on like RAG systems and like showing that you can kind of make the language model retrieve information and like spit it out verbatim, and like this grows with model size. Yeah, so this is like an example where like reproducing, you could reproduce like the 7B, 13B. We don't need you to do like the 7BB to get the result here. And then this one is kind of on like pruning, or like doing very like pruning low rank modifications to remove these like safety critical regions, and then show that that can like increase the attack success rate. Okay, so yeah, again, like look through the papers on your own time. They'll involve like, depending on the paper, it'll involve like you might have to reproduce the data set, or like scale down the models, or like these variations of things. So like make sure you read through them and like understand what's involved kind of to get the main result. But the TLDR is that given that like we don't so much care about the precise like reproduction, like this figure needs to match 100% what they have in the paper, but like that you're replicating their method, that you're getting kind of at the main idea, getting the gist of it, and that like you can figure out like one or two different directions to choose to explore. So like a couple of variations or like interesting extensions. Come to office hours and chat with us. We'll be happy to discuss your projects, and we hope that like you can get something out of it and find interesting things.
Thank you. Sorry for our break today. Next week we'll have 2 experiments, and I'll send out like the pre-reading shortly. By the way, I guess people know, but let me remind you, my office hours are